Okay, so we're going to start talking about exponents, and we've done this in the past. So some of this will be a review, but still take notes. So if we have the number 25, that's a great number, but we could write it out a little bit differently. We could write it as a product of its primes, 5 times 5. But if it's anything bigger than just a few numbers multiplied together, we would like to write it as an exponential form, which would be 5 squared. So that's our first thing we need to talk about is exponential form would be 5 squared. And we can read these different ways. So 5 to the power of 1 we read as 5 to the first. Five to the power of 2 we read as 5 squared. Five to the power of 3 we would read as 5 cubed. And then after that, it kind of goes back to like first whatever. So 5 to the 4th is just 5 to the 4th. So the only special ones are the second and third powers, which are squared and cubed. So if I have a b raised to an n, we need to know what the different parts of this are. This is our base, and this is obviously our power or exponent. And so we could read this as b to the nth power. And what does that n actually tell us? Well, it tells us how many times we multiply b together. So, for example, if I had 6 to the 4th, that means I multiply 6 together 4 times. So let's see if we can work backwards on this one to write -2 times p times q times 3 times p times q times p, and I want to write that in exponential form. So you should multiply together the 2 and the 3, which gives us -6, and then I start counting up my p's. So I have 1p, 2p, 3p. That would be p cubed. And I go back and count my q's, 1q, 2q, or q squared. So we do need to be careful with some negatives. There is a difference between -3 to the 4th and -3 to the 4th. What's the difference? Well, it's where our negative is grouped. This is negative, or the opposite of 3 to the 4th, versus -3 to the 4th. Because they don't always give you these parentheses around that, versus this they will give you parentheses around. What does that mean? Well, this is the negative of 3 times 3 times 3 times 3, or the negative of 81, versus this is -3 times -3 times -3 times -3. -3 times -3 is 9. -3 times -3 is 9. 9 times 9 is 81. So here we get a positive answer versus here we get a negative one. So you do need to be careful on that. The other thing that we've talked about before with negatives in exponents is when the exponent itself is negative. Okay, so we know that 3 squared is 9. But when that exponent is negative, I'm going to move my number to the denominator. And so I will have 1 over 9. Another way to think about this is 1 over 3 squared, because when I move it to the denominator, it becomes a positive exponent. And 1 over 3 squared is 1/9. So let's try this one. X times y to the negative 2. So if you think about it, x has that first power there, and we just don't see it. It's kind of an understood thing. So we'll leave x in the numerator, and then we'll move y squared, and that squared does become positive, into the denominator. One other thing we need to mention here. Anything to the 0th power is one. Okay. Lastly, x plus y quantity cubed is not the same thing, as x cubed plus y cubed. We will get to this later when we talk about polynomials times polynomials, but this is really saying x plus y quantity times x plus y times x plus y. And when we learn how to multiply all these polynomials together, you'll see it's not this. So we'll come back to that at a different time. Okay, so we've also talked about laws of exponents before. So we're going to go through this kind of fast. If I have a to the 5th over a cubed, so I have two things with the same base, what do I do to simplify? Division with the same base, I'm going to subtract down. So 5 minus 3 is 2. My answer would be a squared. What if I have the same base, but they're multiplied together? So a to the 6 times a squared. With multiplication, I'm going to add these together. Six and 2 is 8, so my final answer would be a to the 8th. The last law of exponents. I have a to the 6 in parentheses, and I'm squaring that whole thing. So I only have one base. What do? I multiply the exponent through. And if there's more things in parentheses, I distribute the 2 to all of them. So this would be a to the 12th. Let's try another example of this. If I have 2x to the 4th, y, z. So I have more than one base, but I can't combine the bases. But I'm raising all of it to the 5th. So try this one. Well, I should distribute this 5 to all the different parts. And remember, y and z have an exponent, and the 2 have an exponent of 1. So that would be 2 to the 5th, which I'll need to simplify, x to the 20th, because I multiply 4 and 5, y to the 5th, because 1 times 5 is 5, z to the 5th, because 1 times 5 is 5. So finally, I'll get 32, x to the 20th, y to the 5th, z to the 5th. I'm going to give you a kind of tricky one that combines a lot of these rules together. A to the 5th, b to the 5th, c to the 5th, over a squared, b to the 5th, c to the 7th. Let's see what we get in simplest terms. Well, first thing I notice is they're not all the same base, so I'm not going to add across, but I can subtract down the same bases. So 5 minus 2 would give me a cubed. 5 minus 5 is 0. 5 minus 7 is c to the negative 2. Now, a cubed will stay the same. We said anything to the 0th power is 1. And I have to put that exponent in the denominator because it's negative, so I have 1 over c squared. If I were to multiply all these together, and let's put them over 1 so I know what I'm doing, the numerator is going to give me a cubed over c squared. Thanks for watching.